So guys, in today's video, we are going to deal with what are the different methods for the preparation of carboxylic acids. That is, in our concept, today we are going to deal preparation of carboxylic acids by using different method. But before starting my point of my concept, first of all, I would like to ask you a question. Can you remember a method? I repeat, can you remember a method in which we have dealt the preparation of the carboxylic acids in our earlier classes? Yes? You want me to repeat the question once again? Can you remember any of the topic from our earlier chapters where we have been prepared carboxylic acids? Of course we have done it. It is because in the chapter of alcohols, we have studied under the chemical properties the oxidation of alcohols. Remember it, recall it, oxidation of alcohols. So first method which we are going to see is from primary alcohols, how one can prepare your carboxylic acid. Can you recall? Yes. That is primary alcohol on oxidation with very good, alkaline KMNO4 with alkaline KMNO4 gives us what? Carboxylic acids. Remember, you can also use with respect to alkaline KMNO4, you can also use sometimes acidified potassium dichromate. So whatever the examples I'm going to give over here, the reagents, they are all acting as an oxidizing agents. Okay, recall it. So of course we will have learnt about alkaline KMNO4. Okay, it is a good and one of the strongest reducing agent. Another oxidizing agent we are going to study, that is called as what? Acidified potassium dichromate. Also there is another which is called as a chromic trioxide. Chromium trioxide in an acidic medium. Okay. What is that? Chromium trioxide in acidic medium. Basically it has been given with a name called as Jones reagent. As we have seen with respect to Tollens reagent, Felling's solution, like that only, this is also a name, that is chromium trioxide in acidic medium. Instead of saying this whole term, we say it as a Jones reagent. So it should strike our brain. Okay, Jones reagent means it's a chromium trioxide in an acidic medium. So these are the common oxidizing agents. Okay, you can use any of the one. When you choose a primary alcohol and any of these oxidizing agent, your primary alcohols are going to get oxidized to carboxylic acid. Mark my words, primary alcohol. For example, if I take a general reaction, RCH2OH, yes, it is a primary alcohol. Why? Because the hydroxy group has been attached to a primary carbon atom. What is that primary carbon atom? The carbon atom which is attached to another carbon atom, or single carbon atom. Alva. So of course now the reaction, how does it goes? So you will be providing with a oxygen which has been given with which one? If I choose an alkaline KMNO4. So what you are going to get? Please note over here RCOOH. Along with that you are going to get as a water. So this is a general reaction where our primary alcohol has been oxidized to its corresponding carboxylic acid. Let me choose a common example. CH3CH2OH. What is this? Ethanol. Yes. So this one, when it is getting oxidized in the presence of our alkaline KMNO4. So what you are going to get? CH3COOH. Please mark my words, because very much important. I am going to deal with it with respect to my reactant and product afterwards. I will be giving a note. So that is the reason again and again I am saying you just see the reactant carbon atoms and the top of your product carbon atoms. Of course, one funda what we have come to know, whenever we are oxidizing our primary alcohol with an alkaline KMNO4, you're going to get an acid. That's the general case. But along with that, we have to also make a note, what are the number of the carbon atoms which is present in the reactant and which are present in the product. Why I am saying this? Because guys, remember, whenever we are doing an oxidation of a primary alcohols, yes, and which is giving you the acid, remember, you will be having, that is in the presence of alkaline KMNO4 ಆಗಿರಬಹುದು, acidified K2Cr2O7 ಆಗಿರಬಹುದು, ಅಥವಾ ನಿಮ್ಮ chromium trioxide acidic medium. Remember, any of this oxidizing agent you are going to use, of course you are going to get an acid from primary alcohol. Along with that, remember, the number of the carbon atoms, I repeat, number of the carbon atoms in both the reactants as well as the product will be same. You can just note over here. Here also we are having the 2 carbon atoms. Here also we are having the 2 carbon atoms. Why I am saying this? Because in certain reactions, in our earlier videos also we have seen where your carbon atoms may get reduced. But this is not the case over here. You will be having the same number of the carbon atoms of that of your primary alcohol getting oxidized to carboxylic acid. In the given example, ethanol has been oxidized to ethanoic acid. Is that clear? Very much important. So one more important reaction. Okay, just take it as a note. If I am going to give you CH3, CH2, 8 times CH2OH. So what is this? 1 decanol, or you can just say it as a decanol. DECANOL. Since total there are 10 carbon atoms. Okay, and all are single bonded and having a functional group of hydroxy. So it is decanol. So if I will give you this reaction is in this way. You have to oxidize it in the presence of acidified chromium trioxide. So what will be your product? Is my question. Nothing much you have to think. How many carbon atoms are there? Totally 10 carbon atoms are there. So my product should also have a 10 carbon atoms, in which 1 carbon atom should be a carboxylic acid group. So how can I write it? CH3, CH2, 8 times, so 8, 9, then comes over here as a COOH, which gives you what? Decanoic acid. Which gives you what? Decanoic acid. So that is the reason I was saying this. So you should not get, what you can say, confused by seeing such a big molecule. Only one thing you have to remember, whenever we are using an oxidizing agent of your alkaline KMNO4 or acidified potassium dichromate or chromium trioxide in acidic medium, that is your Jones reagent, you have to remember that in the reactant as well as in the product, you will be having the same number of the carbon atoms, in which 1 carbon atom will be getting carboxylic group. Is that clear? I hope there is no doubt in it. And of course, this was in the case of a primary alcohol only I am talking. If you are taking a secondary alcohol or a tertiary alcohol, of course, on oxidation they can also give you the acids. But remember one important thing. What is that? They will not have the same number of the carbon atoms. In turn, they will be having the less number of the carbon atoms than that of their parent alcohol from which they have been prepared. Remember, it is with case of secondary and tertiary alcohol. So importantly, 3 notes you have to make a note over here. What is that? Of course, these are the common oxidizing agents. Make a note of it. So when primary alcohol has been oxidized using this common oxidizing agent, we will be getting the acid having the same number of the carbon atoms. First important point. Okay. Second important point, what you have to remember, in case they have been given with a secondary or a tertiary alcohol and they are saying and they have been oxidized, of course they are going to give you the acid. But the product may, whatever the carbon atoms will be there, they will be less in number when compared to that of your parent alcohol. Is that clear? So this was the first important method, of course, which we have dealt earlier also in the chapter of alcohols. It was a quick revision for you. So whenever a primary alcohol has been oxidized under using an oxidizing agent, that is your alkaline KMNO4 or that of your, which you can say as a potassium dichromate, acidified potassium dichromate or a Jones reagent, you will be getting the corresponding carboxylic acid. So this was with respect to primary alcohols. Can you see me with respect to aldehydes, what you can do? From aldehydes. Yes, from aldehydes, how can you prepare it? Of course, we have seen in the alcohols chapter, alcohols na now alkaline KMNO4 hakdaga direct ag namge en bantu, we were getting as that of your RCOH because it was the strongest reducing agent. Even if you use the mild reducing agent like that of your PCC or your Tollens reagent, yeah, that is also an oxidizing agent itself, I have dealt with it. You can see the product, what you are going to get over there. So whenever you use a mild oxidizing agent, even your aldehydes can get oxidized to corresponding carboxylic acid. And do remember, here also the number of the carbon atoms remains same. So let us have one example for this. First of all, I would just choose my common reaction, a general reaction where your aldehyde is getting oxidized under the presence of alkaline KMNO4. So here you will be getting as RCOOH. Yes, of course, here also I have used my alkaline KMNO4. There is no need that you have to use the same thing. Even you can use the mild oxidizing agent, I have said earlier, your PCC or your tolerance reagent or your Felling solution. Even a mild oxidizing agent is enough to convert your aldehydes to corresponding carboxylic acid. If I take a common example, CH3CHO, yes, which has been oxidized in the presence of alkaline KMNO4, you will be getting as what? CH3COOH. So in the first case, we have learned that how does ethanol is getting converted to ethanoic acid. Yes, here what we are seeing, ethanol is getting converted to ethanoic acid. It is not that they should ask you in the direct reaction itself. E reaction ko to kuda they can ask you. So give a method in which you can convert ethanol to ethanoic acid and ethanol to ethanoic acid. Either ways are possible. Yes. So you should be very much aware whenever we are writing a reaction, you have to study the reactant name and also the product name. Of course, whatever the reagents you are using. The reagents plays a vital role, guys. Okay. You have to remember the importance of the oxidizing agents and certain reducing agents also. So these were the two important parts which we have come to know, that how one can prepare carboxylic acids using our aldehydes and alcohols. Is that clear? So next let us deal with another important part, that is from alkyl benzenes. From alkyl benzenes. Very interesting part, because here we are going to learn certain important notes over here. An important additional information will be given under this topic. So pay attention. So guys, first of all, we will understand that how does we can prepare our carboxylic acid from alkyl benzenes. Remember, whenever these alkyl benzenes are oxidized with the alkaline KMNO4 or even your chromic acid, we are going to get a benzoic acid. First I will write my general reaction. Okay. So this is my alkyl benzene. Okay, CH3. Okay. So when I am going to treat this, first of all, it is getting oxidized along with the presence of KOH. First remember guys, whatever the KMNO4, alkaline KMNO4 we are using, that is giving this oxygen. Okay. First what you are going to get is the potassium salt of a benzoic acid. Potassium salt of a benzoic acid. Then on acidification, then on acidification, that is you can use your HCl, where you will be getting our corresponding benzoic acid. So this is the actual funda where we can convert our alkyl benzenes to benzoic acid. First of all, you have to oxidize your alkyl benzene in the presence of KOH and alkaline KMNO4. First it is getting oxidized to, or it is will be getting your potassium salt of your benzoic acid. Then on acidification of this potassium salt of a benzoic acid, we will be getting our corresponding benzoic acid. So what is the important part we have to remember over here? It's an interesting reaction. Why is it so? Because you can just see in my notes, I have given a note over there. What is that? The entire side chain is oxidized to carboxyl group irrespective of the length of the side chain. Yes or no? I have said it. What does it mean, sir? For example, if I am going to give you in this way. So here you are having as a CH2, CH2, CH3. Alva. I will ask you what will be the product. What will be the product if I am going to do oxidize it along with a KOH in the presence of KMNO4. This is my first step. Then afterwards in the second step I am going to do it acidification with HCl. What will be the product? I am asking you what will be the product. So remember guys, when I was talking about my alkyl benzenes, I mentioned you what? Alkyl benzenes are only prone to give what? Benzoic acid. Okay. So of course, if you say, sir, it will be giving you CH2, CH2, COOH, of course it is not a benzoic acid and your product is wrong. So what is the product? Of course, we will be getting our benzoic acid. Along with that, we will be also having CH3COOH. So what does it mean? Whatever may be the side chain, whatever may be the length of the side chain which has been attached to the benzene, overall that side chain has to get oxidized to what? Acid. In which one product will be a benzoic acid and another will be an whatever the remaining carbon atoms will be there, with respect to that one you will be having another acid. When it is possible, do remember one important note over here. So this type of a reaction is only possible whenever the benzene is having a benzylic hydrogen. What is that? It is having a benzylic hydrogen. ಏನು sir benzylic hydrogen andre? Remember the position which is adjacent to the aromatic group. I repeat, the positions which are adjacent to the aromatic group, that is called as a benzylic position. Alva, ee position ಏನು ಉಂಟಲ್ವಾ? This position. So this is called as a benzylic position. So even the benzylic position alli benzylic hydrogen idre matra you will be getting our benzoic acid. What you will be getting? The corresponding benzoic acid. So that is the reason, remember guys, yav tara barbodu iga chances of one case you can have in this way. As I mentioned, CH2, CH2, CH3. Alva. Here you can just see that it is having a benzylic hydrogen. First. Second case, I can have in this way, that is CH. Yes, here you want to C, here you want to C, and some other groups you may have. So it is also having a benzylic hydrogen. But if I am going to use my tertiary, that is CH3, CH3. Is there a possibility I can get over here the benzoic acid? Of course not. Of course not, because it is not having a benzylic hydrogen. That is the reason, remember, hence therefore all primary and secondary, all primary alkyl substituent groups and your secondary alkyl substituent groups, whatever may be the length of the chain, yes, length of the carbon chain, it is going to give you the benzoic acid will be pakka one product will be there. Is that clear? Yavag barta untu, whenever you are having a primary alkyl substituent or a secondary alkyl substituent and you are going to oxidize it in the presence of alkaline KMnO4, one pakka product will be there, that will be your benzoic acid. Is that clear? Once you have been given with a tertiary alkyl substituent, of course it is not going to give you the benzoic acid. So that is the reason, unless and until you are not having a benzylic hydrogen, your alkyl benzyls on oxidation, they will not give you the corresponding benzoic acid. Is that clear? Very much important. So this was first important note. Second important note, what does it say? For example, now you are having like this structure. A fused ring ante ಹೇಳ್ತೀವಿ. ಒಂದು ring ಜೊತೆ ಇನ್ನೊಂದು ring fuse ಆಗಿದೆ. So it is a fused ring. So ಈ ತರ ಒಂದು benzene ring also, they can also undergo the oxidation to give you the corresponding carboxylic acid. ಏನಾಗುತ್ತೆ first when you are treating with the alkaline KMnO4 in the presence of KOH, first it's a very much important product whatever we are going to get. First you will get oxidized to COOK like this. ಈ ಒಂದು ರಿಂಗ್ ಇಲ್ಲಿಗೆ ಬ್ರೇಕ್ ಆಗುತ್ತೆ, ಇಲ್ಲಿಗೆ ಬ್ರೇಕ್ ಆಗುತ್ತೆ, ಇಲ್ಲಿ ನಮಗೆ COOK ಅಂತ ಎರಡು ಬರುತ್ತೆ. ಅಫ್ ಕೋರ್ಸ್ ಇದನ್ನ ಏನ್ ಮಾಡ್ತೀನಿ ಈಗ ಅಸಿಡಿಫಿಕೇಶನ್ ಮಾಡ್ತೀನಿ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ನಿಮ್ಗೆ ಏನ್ ಬರುತ್ತೆ? ಸೊ ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ COOH and a COOH, which is called as what in a common name? Phthalic acid. Phthalic acid. Yes. So like this also it is a possibility is there. Okay, so compounds containing the ring structure which has been attached to the benzene can also undergo the oxidation. Okay, evil part can also go oxidation, where you may get this is one common example I have used. This is one more important thing. And remember, as I mentioned, your alkaline KMnO4 is the strongest reducing agent. Alva. So even if your compound is having an aldehydes or a ketone groups, I repeat, even if your aldehydes or ketone groups are present, they will also get oxidized. For example, if I will be using over here as COCH3 and here I am having my CH3. And of course, this is in the presence of alkaline KMNO4 and KOH. This is my first step I will be doing. And in my second step, I will be doing my acidification. First ಏನ್ ಮಾಡ್ತೀವಿ, okay, this is an alkyl benzene ಅಲ್ವಾ, ಯಾಕೆ at a benzylic position we are also having a benzylic hydrogen. So of course ಏನಾಗುತ್ತೆ, ಒಂದು benzoic acid ಬರಲೇಬೇಕು. So first ಏನಾಗುತ್ತೆ, alkaline KMNO4 in the presence of KOH, ಇದು COOK ಆಗುತ್ತೆ, on acidification COOH ಆಯ್ತು. But along with that one, alkyl benzene is also having a ketonic group. ನಾನು ಅದೇ ಹೇಳಿದೆ, ಯಾವ ತರ ನಾವು reagent ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, that is very much important to know its importance. Since alkaline KMNO4 is the strongest reducing agent, it will oxidize both the groups. Even it will oxidize your alkyl group, even it will oxidize your ketone groups. So the final product, you will be astonished to know, both will be getting oxidized to your corresponding carboxylic acid. Both will be getting oxidized to carboxylic acid. First, idu kuda COOK agutte, idu kuda COOK agutte. On acidification, both will be getting oxidized to carboxylic acid. So you have to remember the third important note. Groups like aldehyde or ketones also get oxidized to carboxylic acid. Also get oxidized to carboxylic acid. So importantly, we have come to know three important notes. What are those? Of course, whatever the point I'm giving, guys, remember it's an additional information important for competitive exams. I know that many of you students will not be able to go through it. You just focus on what is the important reaction I have given earlier. Ishta part mada examic bekirod. I am only giving the additional information. Those who are preparing for competitive exams in a better mode, these are the common things which we fail to recognize whenever we are studying it. Okay, remember, important note for the guys who have been very much willingly studying for competitive exams. Remember, alkyl benzenes, if it has to give you the benzoic acid, remember what it should give you. It should have a benzylic hydrogen. So that is the reason your primary alkyl substituents and secondary alkyl substituents on oxidation with an alkaline KMNO4 followed by acidification will be giving you the one common product, that is your benzoic acid. Whatever may be the length of those chains, one important product will be a benzoic acid and another will be a break namadi chain. You just break the chain and whatever the remaining carbon atoms are there, you make one more carboxylic acid. That is the reason I have given one note in my notes. Whatever may be the length of the side chain, overall side chain has to get oxidized to carboxylic acid. Okay, in which one pakka product will be your benzoic acid itself. Then second most important thing what we came to know, even if you have a ring which has been attached to the benzene, they can also get oxidized to the corresponding carboxylic acid. And the most important thing, along with an alkyl substituent, if you are having an aldehyde or even your ketone, they will also get oxidized to corresponding carboxylic acid. So these are the three additional information, I repeat, additional information which are important for your competitive exams. Is that clear? So till now we have come to know that how one can prepare carboxylic acids from aldehydes, from ketones and from that of your alkyl benzenes. Is that clear? So next important part or the important method we are going to deal, that is from nitriles. I repeat, from nitriles. RCN idre, how can you prepare your carboxylic acids? So the next important preparation we are going to study is from alkyl cyanides. Alkyl cyanides, or we can also call it as a cyanoalkanes. Cyanoalkanes, or even sometimes you can also call it as an alkane nitriles. All are same itself. What is the general thing? That is RC triple bond N, or a simple words RCN. So how can we convert this compound to the carboxylic acid? We have seen with respect to aldehyde, we have seen with respect to alcohol, we have seen with respect to the benzylic carbon atoms. This is somewhat new. I think this will be a first important thing where we are going to see that how does a cyanide group, how does a cyanide group is getting converted to that of your carboxylic acid. Very interesting and very easiest part. So actually what we are going to do is, first of all, we are going to hydrolyze it. What we are going to do? We are going to hydrolyze it with a dilute hydrochloric acid. With a dilute hydrochloric acid. That is, we are doing an acid hydrolysis. Okay. So first remember, you are going to get an amide. RCONH2. Very much important these products are. Okay, notebook now. So first when your alkane nitrides or that of your alkyl cyanide has been hydrolyzed with a dilute hydrochloric acid, first important product we are going to get as an amide. Which on further hydrolysis gives us the corresponding carboxylic acid along with ammonia. Certain peoples, or when I was a student, I was always having a doubt. What is that? How can we know that the reaction has been completed? Alva? Okay sir, ಈಗ ನೀವು ಹೇಳಿದ್ರೆ alkyl cyanide acid ಬಂತು. How can we know that acid has been formed? It indicates by the product which you are obtaining along with it. Certain cases, okay, certain cases ಅಲ್ಲಿ product ನಿಮಗೆ smell ಕೊಟ್ಬಿಡುತ್ತೆ. Or we will be testing this. ಈ ತರ ಯಾವ್ದೋ ನಮ್ಗೆ ಇಲ್ಲ ಅಂದ್ರೆ, ಈ ತರ ಒಂದು important byproduct ಬರ್ತಾ ಇಲ್ಲ ಅಂದ್ರೆ, we have to test it by utilizing certain concepts. Like for example, aldehyde ಬಂತ tolerance region test ಮಾಡ್ತೀವಿ, ಅಥವಾ Fehling solution test ಮಾಡ್ತೀವಿ, ಆ ತರ different tests are there. But sometimes in the experiment itself we can analyze, okay, reaction has been complete. How? So you can just see that along with an acid we are also getting an ammonia. So a small, pleasant, or you can say a pungent smell of ammonia can be obtained. So then what is the main funda we have to remember? Whenever alkyl cyanide is hydrolyzed in the presence of a dilute hydrochloric acid, first it is going to give you an amide, which on further hydrolysis gives us the corresponding carboxylic acid. Let us take one important example. That is, if I am going to choose CH3CN, yes, plus water in the presence of a H plus, I would be getting as CH3CONH2. Yes or no? That is, from a methane nitride, I am going to get as an acetamide. Then which upon further hydrolysis gives you what? Acetic acid. The important reaction, because certain cases they can ask you, what is that? How can you prepare acetic acid from methyl cyanide? Yes or no? How can you prepare acetic acid from methyl cyanide? Yes or no? Very much important. Now we still don't know what was that? First important, in primary alcohols, what we saw, they can ask you, how can you prepare acetic acid from ethanol? Yes or no? From ethanol. In the second part, what we saw, how can you prepare acetic acid from ethanol? From ethanol. Yes, like this only. How can you prepare benzoic acid? Okay, let it go with it. How can you prepare your acetic acid from methyl cyanide? Why I am saying this? In all the three cases, we can just notify that the products are same. Yes or no? The products are same, but the only thing is what? We are changing the reactant, and along with the reactant, we are changing certain reagents. Yes or no? So these are the importance of the organic chemistry. So we doesn't stop in one protocol. Of course, we know that we can obtain acids from alcohols. We'll not stop there. We'll be analyzing whether is there any possibility so that we can get the same product by other reactants. Why we do so? Because in each and every field, we always try to reduce the cost. Okay, first of all, we took alkaline KMnO4, which is the strongest oxidizing agent. So it may have certain drawbacks. So we then shift to some other reactant, that is, we can say as a cyanide group. Okay, the very hydrolysis, ಜಾಸ್ತಿ ಖರ್ಚಿಲ್ಲ, ಯಾವ ತರದ ಕೆಮಿಕಲ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ, ಅದು ಬೇರೆ ಕೆಮಿಕಲ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ರು ಕೂಡ ಇಟ್ಸ್ ಅ ಡೈಲ್ಯೂಟ್ ಒನ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್. So it is somewhat cost effective. So we can use this. So like this, analyzing will be very much important in organic chemistry. Not only in organic chemistry, in each and every branch of chemistry. But organic chemistry has this vital role in each and every field. That is the reason I am focusing on the reactions of organic chemistry, and that is the importance of organic chemistry, where one product is obtained by more than one different types of reactants utilizing the different reagents. Is that clear? That is the importance of your organic chemistry. So coming back to our point of view, that is, from alkyl cyanide we can be able to prepare our respective carboxylic acid. How is that? By acid hydrolysis. First of all, it will be giving you an amide, which upon further hydrolysis gives you the corresponding carboxylic acid. So let me give you an example, an important question for you. For example, if I am going to give like this benzonitrile. Yes. So how can you convert this benzonitrile to now benzoic acid? Okay. Of course, alkyl benzene inda gottaitu namge. Hange alkaline KMNO4 in KOH further on acidification gives you benzoic acid. Now I am asking you from benzonitrile. From benzonitrile, or it can also call as a phenyl cyanide or cyanobenzene also we can call it. Okay. I'm just giving you benzonitrile. Now the task is you have to prepare benzoic acid. How will you do it? The same funda. First you treat this one with acid hydrolysis ಮಾಡಿ H+. First ಏನು ಬರುತ್ತೆ ನಿಮಗೆ benzamide ಸಿಗುತ್ತೆ CO NH2, which on further hydrolysis gives you the benzoic acid. Can you see the difference? From alkyl benzenes ಇಂದಲೂ ನಾವು benzoic acid ನ find out ಮಾಡಿದ್ವಿ by using alkaline KMNO4. ಇಲ್ಲಿ ನಾವೇನ್ ಮಾಡ್ತೀವಿ benzonitrile ಇಂದ benzoic acid ನ prepare ಮಾಡ್ತಾ ಇದೀವಿ. No, we are preparing benzonitrile in the benzoic acid. Product is same, but in both the cases, the reactants were different. Remember, your ammonia can also react with your HCl to form ammonium chloride also. There may be a chance. Okay, this is a general reaction I'm just going to give. But the important note, what you have to remember is, whenever an alkyl cyanide has been hydrolyzed in the presence of your dilute hydrochloric acid, first it is going to give you the your amides, which upon further hydrolysis gives us the corresponding carboxylic acid. So in today's video, we have majorly learnt about how can we prepare carboxylic acid from primary alcohols, from aldehydes, from alkyl benzenes. So in alkyl benzenes, we also came to know that only in the case if your benzylic position mein benzylic hydrogen idre matra, we will be getting a benzoic acid, an important note. Then also we came to know that how can we prepare our respective carboxylic acid from your alkyl cyanides or cyanoalkanes. So this much I would like to cover in today's video. In my next video, the another 3 important methods we are going to discuss. Okay, I don't want to confuse you. So first of all, you just pay notice of how can we prepare carboxylic acid from alcohols, from aldehydes, from your alkyl benzenes, and that of your nitriles. Is that clear? So in our next video, we'll be going to see another 3 important methods. There is a major important method we are going to see is the from Grignard reagents also one can prepare our carboxylic acid, which will be dealt in our next video.